Hi, my name is Parth Madabhushi, and I'll be explaining to you basically just what k-means clustering is. So, I guess before getting into k-means clustering, let me quickly explain two terms that you hear all the time, and those are supervised learning and unsupervised learning. So, in supervised learning, we have historical data where we already know the outcome, and we're trying to learn from that data to predict something. Linear regression and logistic regression are examples of supervised learning. So, for example, we may know which customers churned in the past and which customers did not. We can still use that historical information to build a model that predicts the probability that another customer will churn. And then there's unsupervised learning, which is different. Here, we don't necessarily know the outcome beforehand. We basically just give the algorithm data and ask it, can you find patterns or natural groupings within this data? And then that's where the k-means clustering comes in. So it's a fairly simple concept. Let's say I have thousands of customers. Let's say I have millions of customers. I'm not necessarily trying to predict whether they will churn or exactly how much they'll spend. Instead, my goal is to understand, are there natural groups of customers who behave similarly? So that's basically what k-means clustering does, is it takes the data and it'll group similar observations together. Now, the k in k-means simply represents the number of clusters that we want to create. So if I say that k equals 3, I'm basically asking the algorithm to find 3 groups. If I say k equals 5, I'm asking it to find 5 groups. And that's an important point because it doesn't automatically know what these groups mean from a business perspective. It basically just finds the mathematical clusters. And then we interpret what those clusters actually represent. So how does it work? Well, at a very high level, imagine that every customer is represented as a point based on characteristics like spending or usage or tenor or activity, basically a data point. Imagine that every customer is represented as a data point. K-means starts with centers. It makes centers for the number of clusters that we've requested. So if I say k equals 3, it'll make 3 centers. And then it looks at the data and all the data points that are spread out, and it basically asks, which cluster center is that point closest to? And then it starts to sort it. So it assigns those individual data points to the nearest clusters, and then it recalculates the center of each cluster based on the points that were assigned to it. And then it keeps doing it. It does it again, and it keeps repeating the same process until the clusters become relatively stable. And that's essentially how this works. So if we were to take a more practical example, let's take a telecom example. Suppose you are a telecom company with millions of employers. You could provide variables such as monthly spend, data usage, product mix, other behavioral information. And k-means could discover several different customer groups. Maybe one cluster contains high usage customers, and another cluster contains price-sensitive, lower usage customers, or another might contain customers with high levels of service or sport interactions, etc. But here's the important part. We didn't necessarily tell the algorithm beforehand that these customer segments existed. The algorithm discovered these groups by finding the patterns and similarities in the data points which it sorted. So once the business once your business understands those clusters, then those clusters can become extremely useful because you can use them for customer segmentation, you can use them for marketing, targeted marketing, you can use them for personalization or retention strategies, or there are many other applications. Now, I guess an obvious question is, how do I know the number of Ks? How do I know whether K should be 3 or 4 or 5 or 10? And the answer to that is that you don't necessarily guess. A commonly used technique is called the elbow method. Without getting too technical, you basically try different values of K, and you look for the point where adding additional clusters stops giving you a significant improvement. So that might give you an indication of what might be a reasonable amount of clusters, but an important consideration is that they have to make sense from a business perspective. So you could mathematically create 10 different customer groups, but if the business can't actually meaningfully distinguish those 10 groups or take different actions for each of them, then having those 10, they may not be particularly useful. And Implementing k-means in tools like RStudio or Python is relatively forward. In RStudio, there's a built-in k-means function, so you kind of just provide the data and so you specify the number of clusters. As an example, you can tell it, take this data set and make 3 clusters, right? So then the algorithm will then run through that data and tell you which observations belong to each cluster. Python works essentially the same way. You can use common machine libraries. You can use scikit-learn. You can specify the number of clusters, fit the model to your data, and then you can analyze the resulting groups. So again, just like many of the modeling techniques we talked about, running the command is the easy part. I guess the more important work is understanding which variables should go into the model and making sure those variables are prepared and scaled appropriately. You need to select a reasonable number of clusters, and most importantly, you need to understand what those clusters actually mean. So all in all, if you just kind of remember one thing from this video, it's that supervised learning tries to predict an outcome using examples where we already know the answer, versus unsupervised learning tries to discover patterns where the answer isn't necessarily already given to us. And k-means clustering is basically the bridge between the two. You're essentially asking, don't tell me what will happen individually, tell me the similarities together. And so once you discover those similarities in the clusters, then that's where your business will really thrive. So thank you.